This is Mr. Rose, and this is lesson 4.1, trigonometric ratios. Please fill out your note sheet as you go through the lesson. A trigonometric ratio is a ratio of the lengths of two sides in a right triangle. The ratio of the lengths of the sides of a right triangle is constant for a given angle measure. The three trigonometric ratios that we're going to be talking about are sine, cosine, and tangent. Now, notice it says that these are concerning the lengths of the two sides of a right triangle. So if you look at the right triangle in the drawing here, we know that the side that is across from the right angle is called the hypotenuse. So let's label that as our hypotenuse. The hypotenuse always stays the same. It's always the longest side of the triangle, and it's always across from the right angle. Now, we want to look at this right triangle in regards to angle A. So here's angle A. Kind of imagine that as an eye looking across the triangle to this side. The eye is looking at what we call the opposite side of the triangle. The opposite side is always across from the angle that we're looking at. And then the other side of the triangle that touches the angle is called the adjacent side. So we have the three sides of the triangle in relation to angle A, the hypotenuse, which is always the hypotenuse, and the opposite and the adjacent, which could change based upon what angle we're looking at. Now, there are three trigonometric functions or three trigonometric ratios that go along with this drawing. In regards to angle A, we have something called the sine. The abbreviation is SIN. And if I want to do the sine of angle A, we make a fraction or a ratio out of that by taking the length of the opposite side over the length of the hypotenuse. If we want to find the cosine, the abbreviation is COS. We want to take the ratio of the adjacent side over the hypotenuse. And if we want to find the tangent, the abbreviation is TAN, we want to take the opposite over the adjacent side. Now you need to know these trig ratios, and a really easy way to remember this is a mnemonic that we call SOHCAHTOA. It stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you can remember SOHCAHTOA, you can remember the three trigonometric ratios. Let's look at some examples. They want us to find the sine, cosine, and tangent for angle U in the triangle over here on the right. So let's mark angle U. That's the angle that we're looking at. And in regards to angle U, this side here, UW, is the hypotenuse. And the side across from angle U is the opposite side. And the side beside angle U is called the adjacent side. So the first thing you want to do is figure out which side of the triangle is which. Now, if I want to find the sine of angle A, I want to do the opposite over the hypotenuse. Remember, SOHCAHTOA. Sine is opposite over hypotenuse. So the opposite side would be 16. The hypotenuse would be 34. And if you can reduce the fraction, that reduces by 2 to 8 over 17. Now let's find the cosine. The cosine of angle A is the adjacent over the hypotenuse. The adjacent side is 30. The hypotenuse is 34. And again, we can reduce by 2 there to get 15 over 17. And now let's find the tangent. The tangent of angle A is found by dividing the opposite by the adjacent sides. The opposite side is 16. The adjacent side is 30. You can divide both those numbers by 2 and get 8 over 15. So the sine of angle A is 8 over 17. The cosine of angle A is 15 over 17. And the tangent of angle A is 8 over 15. We're going to leave these as fractions. Sometimes they may ask you to divide those out and make decimals out of them. Now, in regards to that same triangle, now we want to solve for the sine, cosine, and tangent of angle W. So let's look at angle W here. Angle W is this angle right here. And the hypotenuse, if you'll remember, always stays the same. It's always the side across from the right angle. Always the side across from the right angle. So the hypotenuse will never change. Now, the eyeball here is looking at this side over here. That's going to be our opposite side. And now the side right beside of the angle is going to be WV, our adjacent side. So notice that when we switch angles, we switch the opposite and the adjacent sides. All right, so the sine of angle W, and by the way, I made a mistake earlier. I did the sine of A and the cosine of A and the tangent of A. Those should have all been U's because that's the angle that we were working with there. Let me fix that real quick. There we go. Now that's fixed up. Let's go back to angle W now. The sine of angle W is the opposite over the hypotenuse. The opposite is 30. The hypotenuse is 34. Those reduce by 2 to 15 over 17. The cosine of angle W is adjacent over hypotenuse, and the adjacent side is 16, the hypotenuse is 34, and both of those reduce by 2 to 8 over 17. And now the tangent of angle W is the opposite over the adjacent. The opposite is 30. The adjacent is 16. Both of those will reduce by 2 to 15 over 8. Now, I don't know if you were paying attention as I was going through that problem, but if you will look at the last two problems that we've done, we had two different angles in the triangle that were not right angles. We had angle U and angle W. The sine of angle U was 8 over 17. And the cosine of angle W, the other angle, was 8 over 17. Also notice that the cosine of angle U was 15 over 17, and the sine of angle W is 15 over 17. So the sine of one angle is the cosine of the other, and vice versa. Now, as far as the tangents are concerned, notice that the tangents of the two angles are reciprocals of each other. Remember, a reciprocal can be formed when you take a fraction and flip it upside down. So that's a really easy way to check yourself when you're finished on these to make sure that you've got the right answers. Let's look at the next couple of examples. Find the sine, cosine, and tangent ratios for angle S. Angle S is this angle. And if we look and find the hypotenuse, remember the hypotenuse is always across from the right angle. So that's going to be the hypotenuse. And let's look at our angle as an eyeball. It's looking at this side of the triangle, so that's the opposite side. And the other side that's left over, that's right beside of the angle, is the adjacent side. All right, so if I want to find the sine of angle S, let's do SOHCAHTOA again. The sine is the opposite over the hypotenuse. So the opposite is 28, the hypotenuse is 53, and that will not reduce. The cosine of angle S, the cosine is equal to the adjacent over the hypotenuse. So that would be 45 over 53, which again will not reduce. And then the tangent of angle S, the tangent is the opposite over the adjacent. So that's going to give me 28 over 45, which will not reduce. Now they want me to look at angle R. Angle R is this angle. Now remember, the hypotenuse is always the hypotenuse. It never changes. The hypotenuse is always across from the right angle. Now this time the angle is down at R and we're looking at this side over here. That's the opposite now. And this would be the adjacent. This is the angle right beside of the, or that's the side right beside of the angle. So remember, the opposite and the adjacent will switch places depending upon which angle you're looking at. Now, if I want to find the sine of angle R, the sine is the opposite over the hypotenuse. So that's going to be 45 over 53. That will not reduce. The cosine of angle R is the adjacent over the hypotenuse. The adjacent is 28. The hypotenuse is 53. That will not reduce. And then the tangent of angle R, the tangent is the opposite over the adjacent. That's going to give me 45 over 28. And that will not reduce. Let's check to make sure that we've got these correct. The sine of this one should be the cosine of that one, and it is. The sine of this one should be the cosine of this one, and it is. And the tangents should be reciprocals of one another, and they are. All right, here's some application problems. It says you walk from one corner of a basketball court to the opposite corner. Write and solve a proportion using a trigonometric ratio to approximate the distance of the walk. We know that this angle right here is 62 degrees. We're looking at this triangle. Here's my right angle, so that means that this X over here is actually my hypotenuse. We're looking at this side over here. That is the opposite side, and this is the side that's left over. That's the adjacent side. Now go back to SOHCAHTOA. And look at what we have here. We don't have any information about the adjacent side, so I'm just going to cross that out and forget about it. What I do have is something about the opposite side, and I'm trying to find the hypotenuse. Opposite and hypotenuse are the two things that I need in order to find the sine. So I'm going to write the sine of 62 degrees, that's the measure of my angle, is equal to the opposite, which is 94, over the hypotenuse, which is x. Now I want to solve for x. Here's a little mathematical trick that you should be aware of. When we have a fraction with a variable on the bottom equal to something, you can switch those two things around and still have a true statement. So I can take this x and switch it with the sine of 62 degrees, and this equation will still be true. So this is going to give me x is equal to 94 over the sine of 62 degrees. You're going to have to use a calculator to work this out. You need a scientific calculator that's got a sine button on it. You may have to put 62 in parentheses. And there's also usually a button that says DRG on your calculator. Make sure that it is set on D for degrees. You want to make sure that you're measuring your angles in degrees. So if you divide that out, 94 divided by the sine of 62 degrees, that comes out to approximately 106.5 feet, because that's the distance from one corner of the basketball court to the other. Here they want me to use the tangent ratio to find x, this x right here. Now this is the angle that I know, that's 31 degrees. This is the side across from the right angle, that's the hypotenuse. This side over here is what I'm looking at from my angle, so that's the opposite. That means this is the adjacent. Now you will remember that in order to find the tangent, I have to use the opposite and the adjacent. So I don't need the hypotenuse this time. So the tangent of 31 degrees, that's how big my angle is equal to the opposite, 17, over the adjacent, which is x. Just like before, I'm going to flip those two pieces of the equation to get another equation that's just as equal. So x equals 17 over the tangent of 31 degrees. Once again, you may have to put 31 degrees. Just put 31 in parentheses in your calculator. Make sure you're set on degrees. Once you set it on degrees, it will stay there until you change it, so you won't have to worry about that every time. But if you divide that out, 17 divided by the tangent of 31 degrees comes out to be about 28.3. Here's another application problem. They want to know how tall the lighthouse is to the nearest foot. So we have a right triangle here. Here's my right angle, so that means the side across from that would be my hypotenuse. Here's the angle that I'm looking at, that's 62 degrees, and it's looking at this side, which would be my opposite side. And this side right here is right beside of the angle, that's the adjacent side. Now, I don't have anything in the problem about the hypotenuse. I don't have any information about that, so just ignore that. We have opposite and adjacent, and if I look at SOHCAHTOA again, opposite and adjacent are what I need for tangent. All right, so let's do tangent of our angle, which is 62 degrees, is equal to the opposite, which is h in the problem, over the adjacent, which is 100. Now this time the variable is on the top of the fraction, not the bottom. So I don't have to do the switcheroo thing that I did earlier. All I have to do to get the h by itself is multiply both sides by 100. So these will cancel each other out and give us h over here. On this side, you want to take your calculator and do 100 times the tangent of 62 degrees. And that's going to come out to be about 188 feet. That's how tall the lighthouse would be. All right, here's some more practice problems. They want us to find the sine, cosine, and tangent for the following angles. Okay, so the first one we want to look at is angle B. Now the angle across, or the side across from the right angle, is the hypotenuse. Remember, you always want to figure out what angle is which first. We're looking at this side over here, so that's the opposite side, which means that the side right beside the angle would have to be the adjacent side. All right, we've got SOHCAHTOA to help us remember our ratios. All right, sine of angle B is going to be equal to the opposite over the hypotenuse. So that's going to give me 48 over 50. Both of those reduced by 2, and you should always reduce if you can. Those reduced by 2 to 24 over 25. Now we can do the cosine of angle B. The cosine of angle B will be the adjacent and the hypotenuse. So the adjacent is 14. The hypotenuse is 50. Both of those reduced by 2 to 7 over 25. And now the tangent of angle B. The tangent is the opposite over the adjacent, and that's going to give me 48 over 14. Both of those reduced by 2 to 24 over 7. Now let's look at angle C. Angle C is over here. And remember, the hypotenuse is always the hypotenuse. It's always the side that does not touch the right angle. It's always the longest side. It's always the side across from the right angle. We're looking at this side over here. This is our opposite side. And the side that's beside the angle is called the adjacent side. So for angle C, the sine of angle C is going to be the opposite and the hypotenuse. So the opposite over the hypotenuse, that reduces by 2 to 7 over 25. The cosine of angle C. Cosine is adjacent over hypotenuse. So that's going to give me 48 over 50. That reduces by 2 to 24 over 25. And then the tangent is the opposite over the adjacent. So the tangent of C is the opposite, which is 14, over the adjacent, which is 48. That reduces by 2 to 7 over 24. Just like before, I said it's a good idea to check these. Remember that the sine of one angle should be the cosine of the other and vice versa. So the sine of angle B is 24 over 25, and the cosine of angle C is 24 over 25, so those match up with each other. The cosine of angle B is 7 over 25, and the sine of angle C is 7 over 25, so those match up with each other. And then notice that the tangents are both reciprocals of one another, so that's an indication that we've got this correct. We want to do the same thing on this next triangle. Once again, we've got SOHCAHTOA. It's always a good idea to write that up there so we can refer to it. We want to start with angle B. Angle B is right here. The side across from the right angle is right here. That's the hypotenuse. And we're looking at this side over here. That is the opposite side. The side beside the angle is the adjacent side. So the sine of angle B, the sine is the opposite over the hypotenuse. So that's going to give me 21 over 29, and that will not reduce. The cosine of angle B, the cosine is the adjacent over the hypotenuse. So that's going to give me 20 over 29, and that will not reduce. And then the tangent of angle B is going to be the opposite divided by the adjacent. The opposite is 21, the adjacent is 20, and that will not reduce. Now for angle C, remember that the hypotenuse always stays the same, so that's still going to be the hypotenuse. This time we're looking at this side of the triangle, so that's going to be my opposite side. And this is beside the angle, so that's going to be the adjacent side. All right, so the sine of angle C, sine is opposite over hypotenuse, so that's going to give me 20 over 29, and that will not reduce. The cosine of angle C, cosine is adjacent over hypotenuse, so that's going to give me 21 over 29, and that will not reduce. And then the tangent of angle C, tangent is opposite over adjacent. Opposite this time is 20, and adjacent is 21. There's my tangent. Let's check these to make sure that we've got them correct. The sine of angle B is 21 over 29. So that should match up with the cosine of angle C, and it does. The cosine of angle B is 20 over 29, and that should match up with the sine of angle C, and it does. And then the tangents should be reciprocals of one another, and they are. Here's another application problem, this time about a railroad crossing sign. We have a right triangle here. Here's my right angle, so directly across from that would be my hypotenuse. This is the angle that I'm looking at, and it's looking at this side of the triangle, so that's my opposite. And this side down here is my adjacent. They want me to find both X and Y, so I'm actually going to have to do two problems here. All right, if I want to find X, notice that X is the opposite side, and the only other side of the triangle that I know is the hypotenuse. Opposite and hypotenuse, if you look at SOHCAHTOA, opposite and hypotenuse make up the sine. So we want to do the sine of 35 degrees is equal to the opposite, which is X, over the hypotenuse, which is 20. Now we don't have to do the switcheroo here. All we have to do to get that X by itself is multiply both sides by 20. So X is going to be equal to 20 times the sine of 35 degrees. And that comes out to be 11.5 feet, since we're measuring in feet. Now, as far as Y is concerned, Y is the adjacent side. And again, I know the hypotenuse. Adjacent hypotenuse is cosine. So the cosine of 35 degrees is equal to the adjacent side, which is Y, over the hypotenuse, which is 20. Just like before, I want to multiply both sides by 20. And that's going to cancel out over here and give me Y. 20 times the cosine of 35 degrees is 16.4 feet. So X is 11.5 feet, and y is 16.4 feet. Here they want us to use a trigonometric ratio to find x. So the angle that I know on number 7 here is this angle here. It's 59 degrees. Remember the angle, or I'm sorry, not the angle, the side across from the right angle is always the hypotenuse. The side that the angle is looking at is the opposite, and the side beside the angle is the adjacent. If you look at what we have in the problem, they want to know about the opposite and the adjacent. We don't know anything about the hypotenuse, so just ignore that. So if I have SOHCAHTOA, I have an O and an A. That's how we find the tangent. So the tangent of 59 degrees is equal to the opposite, which is x, over the adjacent, which is 21. We don't have to do a switcheroo here. All we have to do to get the x by itself is multiply both sides by 21. And when we do that, x comes out to be 34.9. You'll need to do that on your calculator. Again, don't forget you may have to put parentheses around 59 and make sure you're set on degree mode. If you're getting different answers than what I am, that's probably what the problem is. You're on some other mode besides degrees. If you have questions about how to change the calculator on that, please message me or email me, and I'll be glad to help you with that. All right, on number 8, we want to know x again. They gave me this angle, which is 63 degrees. The side across from the right angle is always the hypotenuse. The angle that we're working with is looking at the opposite side, and the side beside the angle is the adjacent side. Now this time, again, we don't know anything about the hypotenuse, so we can kind of ignore that. I know the opposite, and I'm trying to find the adjacent. Once again, that is the tangent function. So the tangent of 63 degrees is equal to the opposite side, which is 13, over the adjacent side, which is x. Now this time the x is on the bottom, so we are going to have to do the switcheroo. And when we do that, x gives me 13 over the tangent of 63 degrees. Now you need to plug that into your calculator and work that out. And when you do that, you come up to about 6.6 after you round it off. That concludes our lesson. If you have any questions, please contact me, and I'll be more than happy to help. Thank you.